Hello everyone, welcome to my channel. Our today's topic of discussion is determination of domain and range of a function. Now the students who are in class 11 already know that there is a very important chapter which is function in your syllabus, maths syllabus. So in case of function, we know that all the elements, I repeat, all the elements of the domain set are mapped under that defined function to an unique element in the codomain set. And we know that this set of elements which are the images of all the elements of this domain set will give us the range of the function. Range of the function. Make sure, students, this range of the function may be the entire codomain set or it might be a subset of this codomain set. But make sure in case of function, when a mapping is a function, then all the elements of the domain set must be mapped, must have an image, unique image in the range, in the codomain set. And the set of all those unique images make the range of the function. You all know this, right? Now, in this video, I'll discuss about the determination, the easiest way of determination of domain and range of a particular function. Let's take one problem. Here, a function from set of real number to set of real number is defined as fx equals to 1 by 1 minus x square, where x is belonging to the set of real number. Means it's a real valued function, okay? We have to find the domain and range of this function. I'll show you the easiest way of finding it. Look, students, here it is given that fx equals to 1 by 1 minus x square. So like here the function, the defined function is given to us. We have to just find out the respective domain and codomain. That is respective domain and range. Okay? So here fx equals to 1 by 1 minus x square. So make sure all the x of the domain, what is to be found, should be mapped, should have an image in the range set under this f. So this f must be well defined, but if you look the structure of fx, you'll find this will be no more defined if 1 minus x square is equal to 0. So obviously we get fx will be defined for all values of x in R, for all those values of x in R which are not satisfying the relation 1 minus x square equals to 0. Okay? For those values of x in the domain set, this particular fx will be defined which are not satisfying the relation 1 minus x square equals to 0. So here we get 1 minus x square should not be equal to 0. So otherwise if it is 0, then this definition will be undefined. Okay, this relation, this particular structure will be undefined in that case. So x square should not be equals to 1. So x should not be equals to plus minus 1. So clearly we get the domain will be the entire real number set except plus 1 and minus 1. So what will be the domain? Real number set except minus 1 and plus 1. How easily we have found it, isn't it? Now let's go for the range. Look, students, let's take the image of every x in the range set as y. Okay, so let y equals to fx, which is 1 minus x square. So here, in order to find out the range set, let's first express x in terms of y. Make sure this will be the easiest way of determining the range. Let's see. Y minus yx square equals to 1. So we get yx square equals to y minus 1. So x square equals to y minus 1 by y. So x equal to plus minus root over y minus 1 by y. Okay, right? So x is represented in terms of y. Make sure, students, this particular presentation is inside the square root sign. So obviously, in order to get the real value of x, we must get this y minus y by y as greater or equal to 0. So y minus 1 by y must be greater or equals to 0. Now from this it is clear also that y should not be equal to 0. Because if y is 0, then this entire relation will be undefined. Okay. So y is not equal to 0. It is clear to us. So let's find out what should be the values of y for which real values will be found as the pre-image in the domain set. So those values of y will give us the range of this f, of this function. So we have already determined that y should not be equal to 0. Now make sure, students, we will get the value of y either less than 0, that means negative, or greater equals to 1. Only in these two cases you will get that this relation will remain greater equals to 0. How? If we consider y less than 0, that means negative. Let's consider any negative value of y, like minus 1, suppose. So this numerator will give us minus 2, putting y equals to minus 1, and denominator will give us minus 1. So this minuses will be constant in both the numerator and denominator, will be getting a positive value. So y less than 0, y less than 0 is satisfying the required condition, that is y minus 1 by y greater equals to 0. And at the same time we get that y should be, or, because either this will happen or y should be greater equals to 1. Because if y equals to 1, then 1 minus 1 will give us 0. So 0 by 1 will give you 0. So equal to 0 condition will be satisfied. And if y greater than 1, suppose 2. 2 is positive, 2 minus 1 will be positive, 2 is positive. So this will also be greater than 0. So this particular condition will be satisfied only for those y's which are either less than 0 or which are greater equals to 1. So look, students, how easily, just by representing the pre-image in the domain set X in terms of Y, which is in the range set, we have found the required values of Y which satisfy the given structure, or the structure what is derived. Okay, so what should be the range? Range of the function is either less than 0, means what? Open interval, because less than 0 means negative, minus infinity to 0, or y will be in 1 closed open interval, 1 infinity. In this particular range, we will get the images of all the elements of the respective domain set. So, hope this method of finding the domain and range of a particular function is clear to all of you. Now, hope this video will be helpful for all of you. Take care, stay safe. Thank you so much.